Hi, my name is Dr. Ahmath. Welcome back to the course of Probability and Statistics. In this video lecture, we are going to discuss about the frequency tables. So most of the time, we can collect the data and into the tables. And let's consider these two tables when we have collected and measured the pulse rates of 40 males and 40 females. So we can see some of the values from this table, so the measurements of the pulse rate of the males starts like 68, 64, 88, 72, but this is very difficult to make a summary or the conclusion about the pulse rates of males or females by just looking to the tables or into these tables. So that is why we're going to learn about how to summarize all of these data values in order to draw some better or efficient conclusions about the data. And this type of these small compact tables are called the frequency table. So essentially, we are going to go through all of the data points and categorize them into some ranges. So for example, I can just get this 40 measurements of the pulse rates of 40 females, and I can categorize them by the pulse rate of the ranges between 60 and 69, 70 and 79, 80 and 89, and so on. And I can just count the number of the items or the numbers which fall into that category. For example, if I just create the category between 60 and 69, there are 12 people or 12 women with the pulse rate in this range between 60 and 69. So we can see here that it is 60, 68, 64, 68, 68, 64, and so on. So we can just do this for all the other data values and categorize them into the 70-79 class range or the 80-89 class range, and so on. So this is called the frequency table when we are going to create the categories and then count the number of the items which fall into each of the categories. So let's discuss about the properties of those categories. So I'm just going to work with this table, and in the example of this table, I'm going to call the names of the categories. So we call the lower class limits the minimum values of the class boundary. So essentially here it is going to be the 60, which is the minimum boundary. 70 is the minimum boundary of the second class. 80 is the minimum boundary of the third class, and so on. So the minimum boundaries or the left boundaries of the classes are called the lower class limits. And analogously, the upper class limits are going to be the maximum values of the classes, right? It is going to be 79, 69, 89, 99, and so on. Well, at the same time, we are going to define the class boundaries as the numbers which are in the middle between the two consecutive classes. So in this case, it is going to be the number in between of here. It is going to be 69.5 or 79.5 or 89.5, and so on. The class midpoints are going to be values which are in the middle of the classes. So usually we find them by just adding these two numbers and dividing this into the two. So essentially 90 plus 99 over 2, it is going to be equal to the 94.5. It is going to be the class midpoint. For every class, there is a class midpoint as well. And one of the most important attributes of the classes is called the class width. So which is going to be the difference between the two consecutive lower class limits. So please note that the class width, it is not going to be the difference between the upper class limit and the lower class limit. The class width is always going to be the difference between the two consecutive lower class limits or two consecutive upper class limits. Well, let's say we're given this table when we are going to categorize the concentration of the tar in non-filtered cigarettes, right? So the cigarettes by the concentration of the tar in the milligrams. So there are only one type of the cigarettes which fall into the category between 10 and 13. No cigarettes fall into this category. 15 type of the cigarettes fall into this type of the category where the concentration of the tar and the milligrams is going to be between 18 and 21, and so on. Well, for this frequency table, I can see here that there are a lot of type of the cigarettes with the concentration of the tar in this range, right? So it is easier to see some of the features of the data from the frequency tables. So now let's just define the attributes of the frequency table. Well, what is the width of this frequency table? So in order to find the width, we need to choose any two classes. For example, let me choose the first two classes. Then I'm going to find the two lower class limits. 10 and 14 are the two lower class limits of this table. Well, in this case, the class width is going to be equal to the 14 minus 10, which is equal to the 4. Again, the class width is not just 3, which is the difference between the upper class limit and the lower class limit for every class. The class width is going to be the difference between the two consecutive lower class limits. So class midpoints are going to be the points which are in the middle of each of the class. It is going to be 10 plus 13 over 2, which is 11.5 for the first class. For the second class, it is going to be equal to the 15.5. For the third class, is 19.5. And for the last class, is going to be 23.5. So the class boundaries are going to be the numbers in the middle between the two classes. It is going to be 13.5 here, 17.5 here, and 21.5 here. So this is how we are going to identify the class attributes or the attributes of the classes of the frequency tables. And it is going to be very helpful when we are going to construct the frequency tables by ourselves. So again, let's look to the frequency table, which shows us the weights in kilograms of the plastic bottles. So we can see here a lot of information. I can see here that a lot of bottles are going to fall into this category, right, between 1 and 3 kilograms. So let's first of all, again, define the attributes of this frequency table or the classes of this frequency table. So the class width in this case is going to be equal to the 1 because the difference between any two lower class limit is going to be equal to the 1, or the difference between any upper two consecutive upper two. Between any two consecutive upper class limits is going to be also equal to the 1. So what is the class midpoint? So in order to find the class midpoints, again, we're going to sum the lower class limit and upper class limit for each category, each class, and divide this to the 2. And the class boundaries is going to be the difference between the upper class limit and the lower class limit of the two consecutive classes and their division to the 2, or the middle point between the lower class limit of the previous class and the upper class limit of the next class. Well, let's do an example and create a frequency table for this data. So let's say we are given the grades of 40 students, and I'm going to create a frequency table of this data. So I'm going to create the table with the 2 rows. In the first row, I'm going to create the classes for the grades, and for the second, we're going to count the number of the grades which fall into each of the classes. So we can see here that the minimum value for the data is equal to the 4, and the maximum is equal to the 60. So probably just making the class width to be equal to the 15 is a good option. Then we are going to have 4 classes. So we are going to first of all define the class widths. Okay. I'm going to start from the last upper class limit, so in order to construct the classes. So now we need to construct the previous upper class limit, and I can do this by just subtracting class width from the upper class limit of the next class. It is going to be equal to the 45, right? So if you remember, the class width is equal to the difference between the 2 upper class limits or 2 lower class limits. The next one is going to be equal to the 30, then the next one is going to be equal to 15. Then I can start, for example, from 1. Okay, so 1 and 15 is going to be the first class, and I can add 15 to the 1 in order to get the lower class limit of the second class. It is going to be equal to the 16. So 16 plus 15, it is going to be equal to the 31. It is going to be the lower class limit of the next class. 31 plus 15, it is going to be equal to the 46. It is going to be the lower class limit of the last class. So once we build the classes, so we can count the number of the items which fall into each of the classes. So let's do this together. So I'm going to go through the first, second, third, and fourth row of the data and count the number of the items which fall into the first class. So let's do this. So it is going to be 8, 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 points which fall into the first category. Let's do this for the second, between 16 and 30. It is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 values in between 16 and 30. Now let's do this for the third class, between 31 and 45. It is going to be 1, 2, 3, 4, 5, 6. There are 6 of them are here, and you may guess the last one. So if there are 40 values in total, we've counted so far 24, 30, then the last one is going to be equal to the 10, right? We can count them. It is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you can see here that the sum of all of the frequencies should be equal to the 60. So this is how we are going to construct the frequency table, and you can see here that the most important part is to create the classes. So you need to look to your data, you need to find the minimum and maximum values, and by just depending on them, you need to decide how many classes you want to have. Then just divide the range to the number of the classes in order to find the class widths, and then try to construct the lower class limits and upper class limits. And then you need to go through all of your data points and count the number of the data points which fall into each of the categories. So this is how we're going to construct the frequency tables. So now the last point which I wanted to discuss with you is the relative frequencies. So sometimes you may get the two different types of the data, or the same type of the data from the two different groups. For example, I may get the grades of the first group with 40 students, and at the same time I may get the grades of another group with 80 students. And if I'm just going to compare the two frequency tables using the graphs, I may not see the differences or the similarities between the two frequency tables or the two groups. Again, I've got one group with 40 students and another group with, here in this table it is written that I've got one group with 70 students and another group with 240 students. So it is very difficult to compare these two data with the numbers. For example, I can see here that 75 is much more from 15, or 20 is much more from 5. And this is not so correct to compare these two tables when the number of the data values in these two tables are so much different. So what we can do is we can find a relative frequency table. So by just dividing 55 to the 240 and multiplying to the 100%, we can find that this is going to be 22% of overall data fall into this category. So 31.25% of the overall data falls into the second category, and so on. And when we are going to do this for both of the tables, we can see here that graphically they're not going to differ so much, as you may see in the previous graph. So this type of the data tables are called the relative frequency tables, when we are going to find, first of all, the frequencies, and then we're going to divide each of the frequencies to the total number of the frequencies in order to get the relative concentration of each of the class. Well, this lecture was about the frequency tables. In our next lectures, we are going to discuss further about the frequency tables and how to sketch their graphs. So far, that's it, what I wanted to discuss with you. Thank you very much for your attention. I hope that this was helpful for you.